Hello, my name is Jerry Wong and this is my presentation for EM1 Project 2. So let's start. So question 1 is separated into two parts. First part being express the following in terms of partial fraction form. Wants us to turn this into a partial fraction form. So due to the highest power of the x's in both the denominator and denominator are the same, the fraction above is an improper fraction. Only proper fractions are able to turn it into proper partial fraction form. So as such, we need to carry out long division. So by carrying out long division, we find that 1 plus that this will equals to 1 plus minus 2x plus 34 over 2x squared plus 2x minus 12. So from here we do, before that we need to, partial fraction conversion, we need to turn this into, we need to fractionize this and simplify everything to get minus x plus 17 over x minus 2, x plus bracket x plus 3. So with this term, this expression, we can carry out partial fraction conversion. So after all it's done, we can find that b equals to minus 4 and a equals to 3. So my final result for the partial fraction form for this expression is 1 plus 3 over x minus 2 minus 4 over x plus 3. So moving on to the second part, hence solving the following equation, it wants us to solve this equation. Since this expression from before is the same as the expression we want us to find in partial fraction form in the previous part, I can we can turn this into its partial fraction form to help us easier to solve this. Notice that there are a pair of similar terms being 3 over x minus 2. As such, by arranging it together and making it into like this expression and comparing it two sides, it shows that it can be said that 1 minus 4 over x plus 3 is equal to 5. So doing algebraic manipulation, I can find that x equals to minus 4. Okay, so that's all for question 1. Moving on to question 2. Question 2, it gives info that a refinery plant is to be built on a plot of land of the shape shown in figure 1 below. The land area for the plant comprises a rectangle of dimensions 2y by 2x kilometers and two semicircles of radius y in kilometer and x kilometer. So in part 1, it wants to find the land area of A in figure 1 as showed it to be this expression. So it also gives us the info that the perimeter equals to pi plus 2, and this is a rectangle and these two are semicircles. So we can find perimeter by using the circumference of a circle formula to find its circumference and adding together everything for perimeter to get this expression. So with this expression, I can sub this equals to pi plus 2, and doing algebraic manipulation and simplification, I'll get y equals to y equals to 1 minus x. Why would I find y first? Is because in the workings later on, I will have y in my workings, while the expression that it wants us to prove it in does not have a y. So by doing this, I can sub y equals to 1 minus x to carry over the y terms in my later workings. So finding area on the total land area, so we can move on here and can use the area of a semicircle formula to find the total area to get everything together to get this expression. So by subbing my y into this expression, I will get this expression in the end, and by doing quite some complex algebraic manipulation, I can get the final expression that it wants us to prove it in. So that's for part A. So part B, determine the values of x and y required to maximize the area available to build the plant. And this part wants us to carry out differentiation. So by changing this into its previous states from the previous workings here to help us do differentiation easier, and after differentiation, dA over dx, I'll get this expression. And maximum area says that dA over dx equals to 0. So by subbing this expression equal to 0, by manipulating it, I can find x equals to half. So when x equals to half, I can sub it back to y equals to 1 minus half to get y equals to half. So I can get the values of x and y. So that's for part B. For part C, hence determine the maximum area available to build the plant. You may leave your answer equal to pi. So with this expression here, I can sub x equals to half. So by subbing it, I can find 1 minus 378 kilometers square in 3SF form for the final answer, or to leave it in terms of pi, I can put it as 1 plus 1 over 4 pi bracket kilometers square. Thank you.